Thank you everyone for joining us today for Create Effective Data Visualizations. We're happy to have you with us today. So my name is Katie Pierce-Ferrier, and I'm the Data Science Strategist for Region 3 at the NNLM. And we have Elizabeth Roth with us today, and she's the Research and Data Science Strategist for Region 2. So just a little bit about us before we get started. I'm going to introduce the network of the National Library of Medicine, also known as NNLM. So as the name suggests, NNLM is part of the National Library of Medicine, which is part of the National Institutes of Health. So we're the education and outreach arm of the National Library of Medicine. We work regionally to get to know communities on the ground and help those communities to better serve the people that they know best. We aim to advance the health and well-being of everyone through access and understanding of how to use health information. So this includes things like working with organizations like libraries, schools, healthcare systems, and all sorts of community-based organizations. So we do this primarily through 3 different methods. We have funding opportunities, outreach, and education. So like today, we offer a wide range of training and education opportunities. And I encourage you all to visit nnlm.gov to learn more about us and find the region that you are currently in. So just a quick look at our agenda. Elizabeth will be going over what a data visualization is, kind of delve into some design principles. We'll look at some common chart types and discuss those. And then I'll be doing a demo of Tableau Public, and we'll be building some of those chart types that we discussed today. So as we go along, if you have any questions, please feel free to drop them into the chat, and we will answer them as soon as we can. And so with that, I'm going to hand it over to Elizabeth to get us started.
All right, thanks, Katie. So we have a lot of information to cover, so we are just going to go and jump right in with what exactly is a data visualization. So to give everyone a understanding, so we're all in the same understanding here, is a simple definition is the graphical representation of information and data. So it's taking raw data and numbers and displaying them in a visual way that exposes trends and relationships. And data visualizations help us both with analysis as well as with storytelling. And as we'll explore in more detail later, this includes charts, graphs, maps, and even a simple table. Math, statistics, information science, those all give us tools to help organize and analyze data, but visualization enables us to see data in a context and communicate its key aspects more intuitively, as well as be more memorable and help someone to fully understand. So it's a very valuable skill to be able to convey your data and outcomes visually. This way, more people can understand your work. And I want to say from the beginning that it is worth mentioning that while data visualizations, of course, should be honest representations of data, it is possible that to have biased visuals, and you may come across those by leaving when the preparer of the visualization has left out some data and emphasized other data. It's important to be aware that this bias does exist, and you want to try to minimize that in your own visualizations. And also when you are viewing visualizations online or articles, just making sure that research data is cited. Because visualizations are such an effective way to help viewers understand information quickly, it does open up the door for misinformation to possibly spread if there is bias or misleading graphics. So I just wanted to mention that. Next slide. So an example of visualizations right here on the screen. So this is a visualization it's a publicly available from Tableau Viz of the Week. And like most quantitative data, which is numeric data, the original format of this data was just a bunch of numbers and labels in a spreadsheet. And if I displayed that spreadsheet to you on this screen, and I asked you what age group spends the most time alone, it would take you a very long time to scroll through all those numbers and kind of figure out a way to find an average just by looking at it. But when we put it into a visual that's colorful and labeled, you can quickly deduce what the data says. And that is older adults are the ones who spend the most time alone, which you can see visually by that being the highest on the graph number point for that age group, as well as re-emphasized in underneath the title. So you could also look at this and tell me what the average minutes a 40-year-old spends with their friends, and also tell me if that's more or less than how much time an 18-year-old spends with their friends. So this visual assists with both the analysis and the storytelling of this data and how Americans spend their time across their lifespans. Next slide. So let's jump into some interactive chats here. If we take a look at this data visualization, what strikes you initially as being not a great example of a data visualization? There's a lot of things that are wrong. They could have made better choices in this. So go ahead and put any comments you have. Someone wrote, makes it look like white people all live in the South. Yes, that's because we are looking at a map. And so we think that the color on the map or the percentages somehow relate to the geographic area, but it's actually not at all the case of this. Map is confusing, looks like the geographic correlation. Yeah, the data is not connected. Map has nothing to do with the data. Axis is confusing. Unclear what the dates stand for. Exactly. Yes, not breaking out all racial and ethnic groups, just lumping as other. Using time progression, yes, showing time progression, which we do often think of time moving from left to right, but when we look at it on a map, that is an east to west or west to east, and that does not make sense. Red draws your attention, implies other populations are important. Is the West Coast stuck in the 1960s? Exactly. This is a very confusing visual. And something else Katie and I talked about right away when we saw this was when we're so used to looking at maps of the United States, and when we see blue and red, we think of political parties. And so our mind went there first too of like, wait, is this saying Republicans and Democrats? Also, the purple being Asian, 8% do all Asian people live in Maine. Like this is a mess. Yes, decreasing red looks like a trending line downward. Yes, so awesome. You are all on the right track. So we're going to go over some of these details, but as you notice, a lot of this is very instinctual. This isn't going to be new to most of you. It's really just we are going to take advantage of these instincts that we already have and use them to convey information more quickly and more efficiently. All right, next slide. All right, so becoming familiar with some basic design principles will help you avoid many of the mistakes shown in that last example. And I use the term cognitive load here to refer to the amount of effort the viewer has to make to interpret your visual. It's like looking in a disorganized closet and trying to tell me how many sweaters you have. It's going to be very overwhelming, but if that closet was very tidy and you know where to look, you could tell me I have 8 sweaters. The goal is to minimize cognitive load to make your data visualization easier to understand and for your data points to shine through. Often the saying less is more applies to data visualization. Less clutter and more white space, background space, less words, and using the words that you do have to make succinct and clear titles, using colors that build on associations that we already have with them. For example, the color green when you're showing an improvement or an increase. Similarly, it's effective to use red if you're showing data that's alarming or something that's out of compliance. And as we'll see later in the example of a heat map, darker shades of colors convey more importance. So even looking at this slide, the first thing you probably saw were the words dark shade. and that's because I made them in bold. And imagine if instead I had bolded the word interpret, you would be confused because your eye went there, but then you're not understanding why that was highlighted. So using dark shades tells our eye exactly where to go. So I'm lastly going to talk about the Gestalt principles. That's going to give additional information about design and working with instead of against the way our mind interprets visuals. So Gestalt is a German word for form or shape, form, shape, or figure. Gestalt psychology helps us understand the way our eye is always seeking to summarize a bunch of parts into a whole, how we distill visual stimuli into meaningful perceptions. Our brains cannot process a ton of visual stimulation, so it automatically simplifies what it sees. So creating visuals that follow these inclinations will help your viewer understand your data visualizations with more ease, speed, and efficiency, and reducing visual chaos. So moving from left to right, and this is actually a visualization that we're looking at here. We start with the term enclosure, and what that means is when we create a visual border around something, our eyes will group those objects together, and this could be done through drawing a box, also shading behind. So in this example here, with the triangles and squares, your eye sees that letter G, shading all of those together. Second example is similarity. We assume that there must be a sameness across objects when they share a trait. So in this example, the dots are configured in the same groupings as the last box, but now some are blue. Oh, sorry, that was a different one. Are yellow. The circles that are yellow, we assume have some shared trait. Continuity. And that is that your eye wants to follow a line. It helps the viewer by creating a visual path. Think about how helpful arrows are. Our eyes love to follow a path. The fourth one is closure, and this explains our tendency to view open structures as closed and complete. So when we look at a bar chart later, we know that the objects all belong inside, even though there's only going to be a line on the left and on the bottom for the axes. We know that it's a full box. Number 5, the connection. This is just the literal connecting of objects with lines that helps us. Proximity, and this is about closeness. When we put objects close together, our mind groups them. So our mind we're seeing the letter L, but we're also seeing some of the X's grouped into their own. And if we had put another color, within those groupings, our eye would see that other additional grouping. And then finally, symmetry. Our eyes also love symmetrical things. So it's going to feel pleasing and harmonious when you have symmetry in your visuals. All right, so some common charts. We put a big X over pie charts here kind of as a joke, but also but not as a joke because they're not very effective in terms of ways to put data together. So we have 7 other data visualization types that we want to emphasize that are going to often be a better choice than a pie chart. So our first one is their simple text. We gave an example here of using a statistic and conveying that visually. 9 out of 10 people struggle to understand health information. And this is helpful when your data, you only have just one number, one data point to put it in this simple format. Next, we're going to move into scatter plots. This is useful for showing a relationship between 2 numerical variables and quickly seeing any outliers. And so this data here is showing gate counts with public libraries and reference transactions. Scatter plots make it easy to see those outliers as well as any groupings, like we can see towards the bottom left corner, there's a prominent number of data points, and then up higher there are much less. Okay, next we move into tables. And so these are useful for especially if you have a table that doesn't have too many data points, these are effective visualizations. If you just want to show so someone can look up and make comparisons, but they're not recommended to use in a presentation or on a slide because of all the focus and attention it takes in looking at all of those numbers, but they are still considered a data visualization. Line charts. This is a line chart you would use to plot continuous data, data that is numeric and measurable as opposed to categorical. This graph is from the European Space Agency Climate Change Initiative, and it tracks how the massive Greenland ice sheet has been steadily declining over time. The graph title and axis are clearly labeled, and it's easy to see how the line trends downward. Line graphs are great for data that's looking at years or decades of worth of information. And if we looked at just 1 or 2 years, we wouldn't be able to see a trend, but spreading it out over 15 years, we're able to see that pattern. Our next visualization is a heat map. And you use heat maps when you need to visualize data in this table format again, but in place of numbers, or even in addition to numbers, as in this one, you would use a color-coded cell that communicates the relative magnitude of the numbers. So in most cases, the darker the shade, the greater the quantity. The table on the right here is a heat map for top 10 reference transactions and their associated gate count numbers in 2017 for public libraries. And the darker shade indicates the higher interval of values, while the lighter shade indicates the lower interval of values. So heat map gives your data a boost by helping the viewer's eye go right to the largest numbers and using that color gradation to show a step down in transactions. This next example is the vertical bar chart, which compares qualitative categories with their numerical values in the form of vertical bars. And most of us are very familiar with this style of visualization. It has a labeled axis, the X and the Y were the bottom, or the X-axis shows the category, and on the side, the Y-axis shows the numerical value associated with each category. In this example, we use regions of the United States broken out, and then their values on the left. And you can quickly see that the South has the highest number of reference transactions. This is also a great example of using titles to help convey your data. So this title comes out and says, Southern states have the most reference transactions. So it keeps the visual simple and clear. You do not need to add additional colors here. It really would just add confusion. There is such a thing as the stacked bar chart if we're going to add additional information, but for this one, keeping the colors the same actually makes it easier to read. The horizontal bar graph is taking the vertical and flipping it on its side, just as a different way to see increase if feels like it makes more sense to look left to right. And in this example, the way that you can see it states going down the left y-axis, and then the number of transactions along the bottom. And sometimes, you could sort this, say, if you want to sort this alphabetically, you could do that, and it would show the difference. For this specific graph, they chose to put it from the highest number of transactions on the top to all the way down to the lowest number. They did choose to turn the bar orange for New York. Not really helpful unless, say, the presentation wants to bring the viewer's attention to New York because we're talking about New York. But because it's the highest, has the highest transactions, we see that by it's the longest bar. We don't need to also identify that as orange. But perhaps they're using the orange to bring attention to New York for whoever they're presenting to. And then finally, we have the stacked horizontal bar graphs, as I was just mentioning, where additional colors can come into play and will be effective when you're adding multiple points into your bar. So a stack bar graph is used when you want to show proportional contribution of these points in comparison to a total. They do require colors because you need to differentiate between the variables. And so in this example, it stacks the top 10 states reference transaction onto its associated gate count. Or no, sorry, we changed that example. I'm sorry. This example is looking at classes that have been taught in Katie's region, Region 3, and how many are from the actual Region 3 who attended, and how many are from outside Region 3. So it will always add up to the total number of attendees, but then it's broken down into what regions they are from. All right, so that's just a quick run through of some common types of charts and graphs. Now we're going to move into some practicing some of these together. So we'll show you this first graph, which has been taken from the book Storytelling with Data. And I'd like you to put in the chat what jumps out at you as being problematic with this data visualization. Yes, the scale of the y-axis does not start at 0. Yeah, the time frame now is not labeled. When is now? Yeah, time usually goes left to right, but now is before 2013. Yeah, especially us looking at it now. When was this developed? Scale is overly dramatic. Yes. Perfect. Okay, so if we look at a corrected version of this, also asking, would a line graph be more suitable? Katie, we go to the next slide. So this changes things. It moves also that axis it was showing on the right-hand side, moving that to the left-hand side, how we're used to seeing a bar graph, changing to start at 0%. And they still have not changed the now. We still don't know when that is, so that wasn't helped. But we now see that huge increase was a bit of an exaggeration when you actually put it to scale. So while the percentages were the same, 35%, 39.6%, is actually not that big of a difference. And so it just gives us a better proportional visual of what the data actually says. Okay, in the second example here, I'd like you to take a look. This is also from Storytelling with Data, and this is for a pre and post test survey data from a summer science class. Say you're taking this data and you want to show to whoever funded this class that there's been some improvement perhaps in the pre and post test. Do we feel this is an effective way to convey that information? Great example of why pie chart's not effective. Yeah, it takes too much work. Cognitive load. I am on overload right now. There are so many colors. My eye keeps having to go back and forth. Hard to read the colors. They're too dark. Too many categories. It's not easy to compare. Yeah, what's the difference between okay and kind of? And that also goes back to the data that you have. Perhaps the survey tool isn't even that good, that the data that you have. Labels are not in the same order as the slices. Yes. So your eye is just jumping around trying to make sense of this. So if we skip to a better version, now we don't have to jump back and forth and compare. We can see, okay, everyone who said board on the pre-test and comparing that right next to the post-test. We're using less colors since those color differences are now conveyed through this having the same label across the bottom. And they changed the title and they said pilot program was a success. So it's telling you already for the outcome of the data, making you have to work even less. So just moving to a simple bar graph made this much easier to understand the data. So we wanted to share a few tools for your toolbox in terms of when you go about to make some of your own visualizations and you want to consider being strategic with your colors as well as accessible and inclusive. And Color Brewer is one of those tools. It's a free tool that identifies colors that will go well together in a visual. You can choose there's sequential, diverging, or qualitative, which will be different ways those colors go together. Sequential colors would be on a gradient, such as in a heat map. The tool will tell you the exact color names and they're listed as hex codes that you can then drop into your visualizing software. And what are hex codes? They're unique universal names for colors that are written with a hashtag followed by a unique set of number and letters. And there's tools online that will help you convert hex codes to RGB. But this is, color is so important with your visuals that it will help you to take some time and make sure that your colors are going to be effective together. An additional tool is this color blindness simulator, and you can actually take a visual you made, you can drop it into this website, and it will let you know if your colors are still visible to someone with color blindness and different types of color blindness, and just help you take that into consideration. Sometimes we want to put red and green together and not thinking how there's a percentage of the population who won't be able to see the difference between those two parts of your visualization. So this is a tool to help you make sure that it is accessible and inclusive in that way. And then Katie's going to share about these two resources.
So before we get into Tableau, I just wanted to point out two other resources that I kind of enjoy using. And one of those is Data Visualization Catalog. So it's exactly what it says on the title. It has a bunch of different types of data visualizations, and I'll give you a brief overview of what it is, what kind of data is good to put in that visualization, in a list of tools that you can go and find that would build those specific data visualizations. So that's a really cool one just to explore different types beyond what we've covered today. My other favorite tool to use is raw graphs. So this is, you're able to just drag and drop your data into raw graphs, and then it will show you all sorts of different charts that you can build with this, and it'll kind of guide you along a little bit. It'll tell you what should go on the x-axis, what should go on the y-axis. So this is really great for just brainstorming. If you're not sure what you want your data to look like, drag and drop it into R graphs, play around with it, get some ideas. I don't necessarily like the visualizations that they create, but again, it's a really good tool for just brainstorming to get an idea of what you want your final product to look like. And both of these are free, so I encourage you to kind of explore those, check those out.
Katie, someone also mentioned in the chat, if anyone codes in R, check out Microshades package as well. It has colorblind accessible palettes built in and has a lot of functions for data viz help. So thank you.
Awesome. That's a good tip. Thank you. So we'll go into Tableau Public. So this is the free version of Tableau. You're not required to pay for it, but it is public. So anything that you create on Tableau Public is open to the public. So if you're trying to do something with any private or sensitive information that you don't want the public to see, just keep in mind that Tableau Public might not be the best tool for that. If you get the regular version of Tableau, the paid version, you don't have to make your visualizations public. But that is the paid for version of it. So there's a couple resources within Tableau that I want to touch on before we start doing the demonstration. So there's Viz of the Day. Many of you probably already heard of that, but this has all sorts of really cool visualizations on it, and it just really shows you everything that Tableau is really capable of, and you can find some cool information on those Viz of the Day. What we'll be working off of today is actually one of their sample data sets. They have a lot of community resources and sample data that you can use from, and we'll be using that today. They have American University data, and that's the sample data set that we'll be working with today to create some of these visualizations. So going over to Tableau, and you're welcome to follow along, but sometimes it takes a little bit of time for Tableau to upload the information. So I have the data set already uploaded into Tableau, just so we can go ahead and jump into everything. If you don't have the data set already downloaded and uploaded into Tableau, this screen will look a little bit different once you log in to Tableau Public. It'll have a big screen that says upload your data, and you'll just click on that, upload whatever Excel sheet or CSV file that you're working in. You'll upload to that, and then there'll be, once you've uploaded it, if you look over towards the right corner, it should have an option to extract that data. So you'll want to extract that and put it fully into Tableau, and this just lets you work on that data and Tableau, have Tableau save that data. I'm working on the website version of this. I kind of prefer the website version of it. I feel like it runs a little bit faster, but there is a desktop version, and it looks pretty much exactly the same. So it's just personal preference for which one you'd rather work with, the online version or the desktop version of it. But both are available. So once you have your data uploaded in Tableau, you have your extract created, and again, keep in mind that sometimes it can take it a couple minutes, especially depending on how big your file is for it to create that extract. But once it's extracted and put it into Tableau, you'll see this screen. So over on the left, we have data definitions, notes on data, and variables. So these are all the sheets that are actually in the Excel file. So you'll drag and drop, like we have data over here. So just drag and drop that over to here. And that lets Tableau know that that's the sheet that we're working on. That's where we want to grab our information from. And down here towards the bottom, it'll have a preview of your data. So you can click update now. So if you've made any changes to your data, you've added some information on or something like that, you'd click update now. And you'd go back through and check all of your data connections and update that information. So now that we have that's covered, down here towards the bottom, you'll see this where it says sheet 1. We're going to start there. We're going to click there, and this takes us to the actual visualization platform. So we just have a blank sheet right here, and just to kind of get you oriented into Tableau to show you where everything is. So I'm going to move my screen around a little bit, make sure I got everything up. So over on the left-hand side, it says data, and then it has all the lists of all the columns and all the information that's captured within this data sheet. So this is where we'll be pulling the information that we'll be working from today. And then over here, we have the marks, and I'll talk a little bit about this as we go through, but this is literally the marks that go onto the graph. So what color it is, if it's a dot, if it's a line, if it's a circle, if there's a label on it, marks kind of controls that right here. And then up at the top, we have our columns and our rows. So the first one that I want to create in Tableau, it's a zip code map. And this is really handy whenever you're working with geographic information. This is a pretty quick visualization to make. So we want to look at the American Data University, and this tells us all about where these, that spreadsheet tells us all about what universities are in the United States, how many students they have, what tuition is like, all sorts of good information about that. So we want to look at where these colleges are. So if I look all through my data, I can find a zip code, and it has kind of like a little globe next to it. So we're going to click on zip code, and we're going to drag and drop it and put it up by columns. And so what that does is it literally puts it into a column. So we just have this giant list of like just giant columns of all the zip codes where all these universities are. So that doesn't really tell us much of anything. So we want to change the map type. So if we come up over to the right-hand side up towards the top, there's a little button that says show me. We'll click on that, and then we'll click on, there's a little map button, and this will actually convert it into a geographic map. So now we have all these dots. This is where all the colleges in the US are located. And now we can see where they are on an actual map, which is pretty cool. But this just tells us the locations, and maybe we want to add a little bit more context, a little bit more information into this. So I'm going to go back over to all the data points that we have, and I want to see highest degree offered. I want to know about whether they offer bachelor's, whether they offer a doctorate. So remember when I said marks, how that kind of helps dictate the marks that are on the map. We're going to drag and drop highest degree offered, and we're going to put that over in marks. So right off the bat, it doesn't actually do anything. We want to go to this weird kind of like tree looking thing that's right by it, and we're going to have to change what kind of mark this is. So we'll click on that, and we're going to change this to color. And so now you can see that this has changed the marks that are on the map. So we now have this legend over here that tells us what all these different colors mean. And Tableau is interactive, which is I always think is really cool. So if we wanted to look at just bachelor's degrees, these are all the universities in the United States that offer bachelor's degrees. These are all the ones that offer master's degrees. So all the ones that are in yellow, and we can look at doctoral degrees. So these are for professional practice. And so now we have a little bit more information on this map about what's going on. So it gives it a little bit more interactive, tells us a little bit more information about everything. And then I want to show you also, you can change the labels that are on this. So right now it's just labeled sheet 1. But if you double click on it, we can change that, and we can put zip code map. And that's not the most descriptive title, but that's just to kind of show you that you can change any of the information that you see up here on Tableau. So I'm going to hit OK. And now we've changed our title. So that's how you make a zip code map. And I'm going to show you a couple different visualizations that we can make in Tableau just to kind of show you what it's capable of. There is a little bit of a learning curve with Tableau, but I've found that it's pretty intuitive for what you want. It's really easy to get in there and just kind of play around with information, switch up the columns, switch up the rows, switch up the different types of marks. And just kind of get familiar with it that way. So Tableau is a really great program. There is some stuff online about how to use it. I'm sure you can find a ton of other YouTube videos to do more complicated visualizations. But this is just to kind of get you oriented with what Tableau has to offer. So if we go back down to the bottom, there's a little box with a plus sign by it. So this is a new worksheet. So we want to create another visualization. So we'll click on this. And now we have sheet 2. And again, we have just a blank page. We can do whatever we want with it. So this time we have the map of where all the colleges are located. But now I want to have the counts. I want to know how many colleges are in each one of these states. I want to know what the numbers of them. So what we'll do is we'll go back over here to the left-hand side, and we'll look back over our data points. And I want to find state abbreviations. So scroll back through here. Okay, and again, down towards the bottom, there's a little globe by it, state abbreviations. And I'm going to drag and drop that. And I'm going to put that in columns. And again, we now just have a bunch of columns listed of all of the states. But I'm going to do that again. I'm going to find state abbreviation, drag and drop, and put it into rows. And so again, now we have a bunch of rows of all the state names and a bunch of columns of all the state names. We have to tell Tableau what it is we actually want to do with this information. So in columns, I'm going to change this. Click on if you hover over it, there's a little triangle, a little white triangle. You click on that. And right now it's dimensions. So that means that it's reading it as text. But what we want Tableau to do is we want to read it as a number. So if we go to measure and then we go to count, this will count the number of times that those states appear. So now you can see up here, it's changed it to green to let you know that it's now looking at it as a numerical value rather than like a text value. And everything's in alphabetical order. And we now know that there's 93 colleges and universities in California, and there's 4 in Delaware. So now we have this individual count information for all of the states. And if you go back up top to the toolbar, this gives you a little bit more information about what you can do with the visualizations. So we have this little ascending versus descending. It automatically puts in alphabetical order, but we can also order it from largest to smallest. So we'll put it in descending order. So New York has the most universities out of any of the other states. They have 122 states. So already we can get some good information out of this. But let's say that I want to, again, add a little bit more context for this. So this is just a regular old kind of vertical chart. But Elizabeth touched on doing stacked charts and kind of putting 2 pieces of information into a bar graph. So that's what we'll create now. I want to look at private schools versus public schools. So if I go back over to my data points, and this is kind of right up at the top, this is the second one on the list. This has control of institution, and this will tell us whether or not the school is public or private. So we're going to drag and drop this over to marks. And again, we'll click on the little kind of tree thing next to it, and we're going to change this to color. So now we have blue. There's 40 public schools in New York, and there's 82 private schools in New York. So this information is separated out for us in a stacked bar chart. So that way it's kind of easier to see, and we can interact with that information a little bit more. But let's say that I really don't like this gray color. I think it's kind of boring. We can do over here is we can come over to the legend and right click on that colors, and now we can edit the colors. So let's say for the private not-for-profit, let's say we wanted to change it to kind of this lighter teal blue. You click on that, and now we have that lighter teal blue and the darker blue. And X out of that, and we're able to change those colors. So you can do this. Tableau has all sorts of different palettes you can use. So if you just wanted to use grays, if you wanted to use, I guess, like jewel colors, there's all sorts of colors that you can go through here. And then keep in mind, like Elizabeth said, that color brewer and the color blindness simulator to make sure that you're trying to use colors that have a high enough contrast ratio that people are able to see them. And I just want to pause real quick. Does anybody have any questions about these 2 chart types before I move on to the next one? Okay, are there any standard ways to think about using patterns that can be printed in black, gray, and white? So I know sometimes with visualizations, they'll have like the lines or the dots kind of as a way to help differentiate. I don't think Tableau might have this, I just haven't come across it. They might have options for doing kind of those texturized ones, but if not, you can always do, like they have like a grayscale that you can use, or like the Seattle grays. I'd recommend doing something like that. As far as textures, I'm not sure. I don't know if Tableau Public has anything, but maybe like the paid version of Tableau might have something too. You don't get as many like the bells and whistles on the public free version as you do with the paid version. And then how do we export these tables charts? I'm going to get to that at the end, but I do cover that because Tableau is great at sharing. So there is a way to do that, and I'll show that as we get towards the end. Okay, so I'm going to move on to our next one, and this time we're actually going to create kind of a scatter plot. So again, we'll go down to the bottom, right where it says sheet 1, sheet 2. We'll click on the little box next to a plus sign. And again, we have a brand new sheet that we can make all sorts of wonderful visualizations with. So like I said, we're going to create a sort of a scatter plot. I want to take a look at average tuition versus the average enrollment at American universities. And so we'll go back over to our data points, and this time we got to scroll all the way down to the bottom, all the way down. And tuition and fees 2013 to 2014. So this data is a little bit old, but it's good to it's a good for an example. So we're going to grab tuition and fees, and we're going to pull this up to the columns. And you can see here that Tableau actually automatically sums this all together. So the total sum of all the tuition and fees in 2013 to 2014 is about $31 million. So we don't want the sum, we actually want the average. So if we go back over to where we have it up here on the columns, we can get that little drop down arrow. And we go to measure. And so you can see that it's already set to sum, but we want the average. So I'm going to select average. And now we can see that the average tuition and fees was just under $21,000. This was about $20,000 was the average tuition in the United States. And then, like I said, we want to compare this over to enrollment. So again, on our data points that we have here, we'll scroll back up and total enrollment. Okay, just a few ones up. So we're going to drag and drop total enrollment, and we're going to put that into the rows column. So again, it automatically did the sum of total enrollment, but we want to change this to an average because we want to look at averages. So click on the little triangle, measure, average. So now we can see that the average enrollment was about 7,000 students and the average tuition was about 20,000. But this just gives us for overall. If this adds everything together on this data set, we want to kind of have a little bit more discrete information. We want to know a little bit more about this. So what we are going to do is we could separate this out. We have all the individual state information, but that's a lot of data points to look at. And I want to show you a couple other features of Tableau. So rather than do it for all 50 states, I'm going to scroll up on my data points all the way back up to the top. And here we have geographic region. So this gives us separates it out by region. So there's not quite so many data points to look at. And I'm going to drag and drop this over to marks. Awesome. So now we have Rocky Mountains region. We have, New England. We have the far west. So now we have this kind of all scattered about on this plot. And Elizabeth mentioned that this makes it really easy to see outliers. So you can see this outlier down here, U.S. service schools. They have a much lower average tuition, much lower enrollment. So they're kind of the outlier all the way down here where these are kind of all grouped up towards this side of the graph. So this, for the marks, this has circles. I think that's a little bit harder to see. So I want to change the marks that are on the graph. So I'll go back over to our little marks box, and I'm going to click on shape. And I like the solid squares, so it's easier to kind of pick out. So I'm going to change those over to solid squares. And again, these are all the same color, so there's no differentiation between this. I want to change the colors. So I'm going to click on the little box, the little tree box by here, and I'm going to change it from the little tree over to color. And so now we have, they're each in their own little different colors. We have the legend over here. So it's a little bit easier to differentiate all of these. So again, we have the Rocky Mountains that are up here. And you can see that they have an higher average enrollment, but a little bit lower average tuition. So there's one more thing that I want to add to this graph just to kind of show you all the cool things that you can do with Tableau. Is we can also add text labels to this. So I want to put the average tuition and fees. So since I'm adding that as a mark, I'm going to scroll all the way back down, tuition and fees 2013, and I'm going to add that to the marks box. So again, it automatically puts it as a sum, but we want the average because that's what our chart is actually looking at. So click on the little drop down, measure, average. And then we're going to click on the little tree here. And because we want the labels, we're going to, it's right underneath color, the little T inside the box. This changes it over to labels. So now this graph, this chart gives us a lot of information. We can automatically look at it and see what the average tuition is at all of these. But since we're looking at two different numbers, it's not automatically, we can't, it adds a cognitive load for us to be able to know that this is $15,000 and not 15,000 students. So I want to change the formats of these numbers so we automatically know that they're currency. So if we go back over to our marks table and we click on, actually, right click on the little T. And up here we have format number. And so it's under automatic format, but this is currency. So we have standard currency and custom currency. I'm going to click on custom because it automatically puts it for 2 decimal points, and I don't really care about the decimal points. I'm going to drop this down to no decimal points. And now we have it on our map. We're able to see the average tuition and fees. It's clearly labeled on here. The colors tell us what region this all is. And again, we can change the name of this chart. And I did that by right up here where it says sheet 3, just double clicking on that. Average tuition. I'm a horrible speller, I apologize. And average enrollment. Click OK. And I'm going to try and rush through this last part so if we have any questions at the end, we can get to it. So down here where we were clicking to create new sheets, if we click on the box with the lines through it, this is a new dashboard. So what this allows us to do is it shows all of our sheets that we have, and we can drag and drop it over to create this dashboard so we can look at all of our sheets that we created in one. And I see here, is there a way to edit the access labels to reflect? Yes, there is. Let me skip back over to sheet 3 here. There is a way. If you double click, yeah, perfect. If you double click on the access labels, and then down here it says title, average tuition and fees, you're able to change this and add information or make it more contextual for it. What is the tooltip option? Where do you see that? I'm not sure where the tool, under marks. Oh, the tool. Oh, okay. So what the tooltips option is you see where we hover over this, it has geographic region and has all this information in there. That's what the tooltip is. So if you want to change the information on here, you can change what that says when we hover over those those individual data points. So when it's in the little I don't remember what those are called, but like the kind of the sideways carrot tops, this tells you where the information, like the actual data points, and this is the description. You can kind of change those tooltips to put in whatever information you want to draw attention to. And then so for the dashboard, like I said, we have our different sheets here. We can drag and drop these over. You can rearrange these however you like. I'm not going to spend a lot of time on that. Just wanted to show you that this is how you create the dashboard so you can look at all of your sheets at once. And then up at the top here, you'll see publish. So like I said, Tableau Public means that everything is public. You can share that with everybody. So I'm going to click publish, save it. And so now we can go to my home page and I'll show you how you're able to share all of these with other people. Actually click on this. Yes, publish. Please save it. Okay. So then when you're on your page for Tableau, so you can see by Katie, that's me. And so we have our test class. And so now we have our dashboard. And then up along at the top, we have all the options that we have for sharing. So the little dots that are connected, this is our share button. So you can embed this, like, so if you want to put it on your website, this will give you the HTML code to embed it into a website. We also have the direct link here. I'll put that in the chat for everybody, just so you can kind of see it as an example. So that's a link out that you can share with anyone. And then the little box with the downward arrow, this is for the download. So now you can download it as an image, you can download it as a PDF, it's a PowerPoint. So Tableau makes it really easy to share it with other people as well. So those are all your sharing options with Tableau. We have just a few minutes left. If anybody has any questions about anything that we went over. Oh, somebody mentioned you might be able to get a non-public Tableau for free for teaching or for non-commercial research. Oh, that's awesome. Yeah, so definitely check that out. We have anytime you can get something for free or at a discount. It's always awesome. And then this is just some more resources that Elizabeth and I kind of like. The Storytelling with Data. It's an excellent book. I'd highly recommend it if you can get a hold of it to do that. And then to export data into Tableau, does it need to be formatted in a certain way in your Excel sheet? Yes, kind of. The cleaner that you have your data, the easier it is it's going to be to put it into Tableau. Tableau is pretty great at recognizing zip codes and dates and things like that. I follow kind of like the tidy data principles. The Library Carpentries has a really great lesson on tidy data, but the cleaner your data is, the easier it's going to be to put into Tableau and to visualize it. Is Tableau the preferred software? Do you recommend other software? I work a lot with Power BI, and so there's kind of pros and cons to each of them. Power BI has some really powerful analytics that I like. In my team that we're on, we do everything through Microsoft Teams, and Power BI can be embedded directly into Teams. So I like Power BI. We also have institutional access, so we don't actually have to pay for it. The university pays for it. R is a great program to make visualizations. Excel will make good visualizations, especially if you just need like a real quick bar graph or something. But Tableau is one of my favorites. I use it for a lot of stuff. I feel like it's intuitive. I feel like you can get really creative with it. So I'd recommend any of those. The data visualization catalog that I mentioned earlier, that will also have recommended software for different types of visualizations you want to create. Are there citation requirements of using for publishing research findings? I think if you're using openly shared data sets, a lot of times those will have recommended ways to cite that you're using that openly available data. So I'm a librarian. I will always say cite your sources, especially with an air of caution. Even if it is open or publicly available, I'd say go ahead and cite it, just so people can find that information again. And yes, I will pull up that link if I can and drop that in the chat for you. Library conference spreadsheet reference. I believe that is, I'm going to stop sharing my screen so you don't have to watch me like go all the way through Google here. But Elizabeth, did I miss any of the other questions?
Asked if you could share the tiny data resource you mentioned. I might also put the link to the survey if you need to leave it as 2 o'clock for the MLACEs, and we would love your feedback on the class as well.
Oh, okay. And then Heather clarified, do we need to cite Tableau as the image source, and how do we do so? Yes, I would if you're using it for something else, and then I guess you just cite it as like a website, because there should be, let me share my screen again real quick. there's a way to get that link directly to Tableau. So even if you're looking at someone else's, there should be this share button up at the top with the little 3 dots that are connected, and then that link. And I would just share that link and kind of reference it as a website to cite the source. We offer a part 2 to this webinar. We don't have one planned. I think we'll offer this again, hopefully in the next few months. And I know that we are working on more visualization classes and more about this. And I know Tableau is a popular resource, so maybe in the future, but we don't have anything concrete planned right now. But keep checking back to our training calendar, and hopefully we have more classes for you.
And we also have the data visualization challenge. Do you want to throw up that slide?
Oh, yes. Yeah, and so this is part of Love Data Week. So we have the data visualization challenge that's not due till March 31st. So get into Tableau, start creating those visualizations. You can win up to $500 in professional development. And we have other classes coming up this week, all in celebration for Love Data Week. So thank you everyone so much for joining us, and I hope you all have a wonderful rest of your day.
Thanks for watching. This video was produced by the network of the National Library of Medicine. Select the circular channel icon to subscribe to our channel, or select a video thumbnail to watch another video from the channel.